Alright, this is Mr. McMurray, and we're going to do the vectors and resultants worksheet today. Should look something like this sheet on the screen there. And we are going to take some different organisms that are moving in different directions, and we're going to draw that on a piece of grass paper to show the vectors and then the resultant, which is how far they are from where they started. Now, to do that, you will need a ruler. You will need a pencil. Now, I'm going to use a pen because I want it to show up better, but you need to use a pencil just in case you make a mistake. You don't have to redo it. Not that you make mistakes, but just in case. I don't want to have to run out a bunch of copies, so we're going to do it in pencil. So if you have your two worksheets and those things, you should be ready to go. First thing we read here, it says we're talking about an ant. All right, and this ant, it says, ran the following distances and directions on top of a picnic table. She ran 7.4 centimeters west. Okay, so the first thing you want to do is mark on your paper the never eat sour watermelons or whatever, soggy waffles. Put an N at the top of your page. Over here on the right hand side, if you'll put E for east. Down at the bottom of your page, if you will put S for south. And then over here on the side, if you will put a W for west, just to remind yourself. All right, now we want to go west. On number one, there's a dot that tells you where to start. You want to start with the dot that it gives you, because otherwise you might go off the page. So let's put that right there. We're going to measure 7.4, so that's 7 centimeters and 4 millimeters. About right there, and we're going to draw a line all the way to there. All right. So you should have one line drawn across your thing going to the west. This would be a vector showing that the ant ran 7.4 centimeters west. All right. Now the next one says that they went, I'll underline that or draw a line through it, so we did that one. The next one says 3.3 centimeters south. All right, so I'm going to use the same one, make sure I'm using centimeters, not inches. And I'm going to draw this down, and it's going to go down 3.3, almost to that line, not quite. I drew a little bit long there, but my pen ink kind of ran, but 3.3 centimeters south. Now, I'm going to go 2.5 centimeters west, so the next vector is going to go 2.5 centimeters west. And so we're going to draw that one from here, whoops, down to there. I got a little carried away there, sorry. Cross that off there. Okay, and then next one's going to go 1.7 centimeters north. So I'm going to make this one go, I'm going to put 1.7 right there at the tip. Notice I'm trying to make my lines parallel to the up and down lines, so it makes nice straight lines. All right, there we go. Okay, and then the next one's going to go 5.4 centimeters east. So I'm going to put that at about 5.4. I'm going to draw a line back the other direction as far as I can. Right, 0.4 centimeters east. All right, then I'm going to go 1.1 centimeters south. I'm going to go south again. And start right there on one, and it's going to go down to 1.1, so about there. All right. And then 1.8 centimeters west. I can tell you already, don't do this with a felt tip pen. That was not a good idea because it bleeds out. But anyhow, it's going to go 1.8 west. All right. And then the final one, that is it. Actually, that is the final one. All right. And it tells us that it took it 7.2 seconds to do this. All right, now we need to fill out the blanks below here. So the blanks below, first of all, is distance. To do the distance, you would just add these up. 7.4 plus 3.3 plus 2.5 plus 1.7 plus 5.4 plus 1.1 plus 1.8. And if you do that, you should get a total of 23.2, I believe. All right, and that would be centimeters. All right, now to find the average speed, we would divide the distance, which is, I'm going to do off the side here, 20, scoot that up a little bit, 23.2. Okay, take that and divide that by 7.2 seconds. If I divide that, I will get 3.222 and repeating decimal. All right, now the question is, how much of that do I want to hold on? Well, this one, the distance, was adding. And so since we're adding, we look at the number of decimal places. They all have one decimal place, so the answer should have one decimal place. But now we're dividing. And since we're dividing, we're going to do it the least significant digits. This one has 3. The bottom one has 2. So we're going to put 2 significant digits. So we're going to do that 3.2, and we're going to drop the bottom part. All right, and this is centimeters over seconds, so centimeters per second. Now that brings us to the last question is, what is the displacement? Well, the displacement is how far we are from where we started to where we ended up and what direction. So first, we're going to measure from that dot to the end of this line right here. And it's about 6.8 and halfway between 6.8 and 6.9. So I'm going to put 6.85 centimeters. Now your units should be using centimeters with millimeters. So you can measure to a tenth, and then you have to estimate the hundredths place. If it's right on something, that would be 6.80. Okay? And if I started from my beginning spot, I would go to the southwest to get to my ending spot. So I'm going to put to the southwest. All right? Hang on. And so if you look at this on the next one, it's going to say that 1 mile equals 1 centimeter. So you're going to use the same scale. 2.4 miles will be 2.4 centimeters. Down here on number 3, it's going to be 10 yards equals 1 centimeter. So to draw this, if it's 43 yards, you're going to do 4.3 centimeters. But when you get to your distance, you need to make sure your units are miles here. And on this bottom one, that your units are yards. Okay, same way we use speed and displacement. All right, so you're going to convert yards to centimeters by dividing by 10 to get how far to measure on your paper in centimeters, but your answer should always be in yards. Have a good time. I hope you did a really good job. See you later.